Well, hello and welcome to this September 9 and 10 edition of the SkyTour LiveStream, coming to you from the John Zack Memorial Observatory in picturesque northwestern Connecticut. Now tonight we have an exceptional night. The moon will be coming up shortly, but it's going to be great. We're going to look at double stars and clusters. So from many stars in a star cluster to double stars, we're going to see it all because that's what we do. As you know, Amanda will be taking questions through the chat and managing that for us. And it's all live and it's all uncut. So hey, I'll talk to you in a couple minutes. The scope is almost acclimatized. The photo on the screen was just taken. Be right back. Oh yeah, so tonight we're gonna be bouncing around the sky, so I figured we're gonna use some bouncy music to do that too. Now the moon is gonna be coming up in a little while, so we're gonna do our best to avoid it or to work around it. It's gonna be nearly full, but before we do this, I gotta tell you, I saw something tonight which defies my ability to explain. And first of all, I want to say hello to everybody. Welcome. I see there's a couple of you out there so far, and I'm sure there'll be more. And I also want to say hello to Amanda. Amanda is with us. Hello, Amanda.
Hi, Mark. Hi, chat.
And we are going to, like I said, we're going to do a nice star cluster tour tonight. The one we have on the screen now is Messier 11, called the Wild Duck Cluster. I don't know why it's called the Wild Duck. We could look that up. But the question, or the thing I wanted to tell you about, was a really interesting thing that happened to me just as I was starting up the observatory. I was looking up in the sky, and I looked up and I said, oh, what planet is that? It can't be a planet. Right? It's too eastward for Jupiter, and it was a bright spot, almost white in the sky, and it wasn't moving. And I was like, wow. That's interesting. So I grabbed my iPad and I looked at it and said, is that possibly a nova or a supernova? Possibly a star that exploded at the end of its life. And when I went back to look at it in the sky, it was gone. Now, it hadn't moved at all, and I was very careful to note its position. And then when I looked back, it was gone. So the only thing I can surmise from a logical point of view is that what I actually saw was a iridium flashing satellite, an iridium flasher we call them, and that it could have been that it was higher up and moving very slowly and I couldn't tell against the other stars, because I looked at it for about 5 seconds and it was staying right there, and I was looking at it, and I'm trained to do this, I always do this. I was looking at it against the other guys in the star, the other stars in the sky rather, and it was not moving. So I was like, wow, that's pretty cool, and I had no idea what it was. But hey, that's what we see sometimes, you know. So that all said, I guess what we're gonna, I'm gonna try to give you a nice experience today anyway. Now I want to tell you, because I'm committed to SkyTour LiveStream and being able to stream and get faster upload speeds and download speeds, I actually went out and I upgraded my internet to be 4 times faster. So now I have several hundred megabits per second download speed and more upload speed. So literally double. So we should no longer have data dropouts, and we should no longer have any kind of issues. Although I will say that the start time for that depends on when my new internet cable modem gets here. Once it gets here, then I can install it, put it on, and make sure that everything's working. So right now we're with the old, but old and lousy goes away, and new and improved comes in, and that's part of the upgrade to the observatory. Little by little.
Yay.
So that's
so
it.
I have a question.
Yes.
How could you have been sitting with a laptop and a telescope and not have a picture of whatever it is you saw?
What do you mean?
Whatever you saw in the sky, and you thought it was a planet, and you were checking out if it was a nova or something?
Well, because if it was a nova or a supernova, it would have lasted for days. in the sky, and hours at the shortest. And
but if it was a UFO, it would have lasted a second.
At
least if you had a picture, you could go back and enlarge it and check out possibilities, right?
Yeah, but the scope wasn't even online yet. I was waiting for the scope to come up, and while I was waiting, I was looking out the dome, and it's like, hey, whoa, what's that thing? And I was like, whoa, that was so cool. And then it vanished, so I figured...
I mean, the chief photo and video analyst for MUFON, and he didn't catch a picture of something unexplainable. I had to ask.
It is embarrassing to me that I didn't catch it. That's correct. And
Daryl says, could it have been Arcturus?
No, Arcturus is way west right now.
Okay.
Yeah, and it wasn't Vega, it wasn't Altair, which was the closest thing to it. I was looking at Altair and using Altair to actually gauge its motion, and there was no motion that I could detect, but Altair was quite a distance from it. So it could have been moving slowly.
I think he got here a little after the story started, because he said if you had the time and bearing, we could look it up. So Daryl is in chat and willing to help.
Yeah, well...
I wouldn't even know where to start, and if you didn't have any luck before it disappeared, what else could have disappeared that fast? Could it have been maybe a meteorite? No, because it wasn't moving.
Well, actually, a meteorite that's coming right at you will be like that in the sky, but it only lasts a fraction of a second. It's very quick. It's like a bright flash in the sky that doesn't have a streak behind it. Those are the meteors that are actually heading right for you.
Mm-hmm.
Those are the ones you actually want to hide from.
I bet.
Well, actually, I'm kidding. But the fact is that it wasn't a meteor, and it wasn't a obvious satellite at all because it didn't move in the sky as it should have. It wasn't a geostationary satellite because I wouldn't expect a geostationary bird to actually, sit there and be so bright. Those geosyncs are actually fairly dim. And if you take a photo of the deep sky, say for 10 minutes, you might find that the stars look beautiful and brilliant, but then you've got this one little star that seems like it's wavering around them, kind of making a little zigzag pattern. That's a geosynchronous satellite, and that's how you can actually catch them, okay? Because you actually take a long exposure of the nighttime sky, and bing, there it is, So it's pretty cool. Now, I'm going to test the night. I'm going to actually, in order to test the night, I'm actually going to go and to one of my...
Because we just saw something fly by the screen. It was pretty fast, so I will guess that it was a bird.
When, just now?
Yeah, a minute ago. Daryl, see, because of the 30-second delay, I'm looking on YouTube. I said, ooh. And Daryl said, there went one just now.
Okay.
And I don't know. I'm assuming it was a bird. It was, I think, too fast for a satellite or a plane.
Well, no, actually it's not, because remember, we're actually at what's called prime focus. And that means that we are looking at the view. We're looking at the view in a very magnified manner. All right. So because we might see a satellite come through. That's certainly not out of the question at all.
But moving that fast, I don't know.
Well, it could come zipping through.
We've seen satellites on here before. I've seen satellites on here, but
yeah, it could have been one that's in a low Earth orbit. By the way, the alignment is right on the money tonight. We actually have a beautiful alignment. We can see. I'm going to do a 5-second photo here of the Dumbbell Nebula, which I said we weren't even going to look at tonight. But I figure we'll look at some of these nebula before the moon makes its presence known. So let's see how it's going to look. Wow. Oh
just looks
boy.
So sharp tonight.
It is just outstanding. Holy cow. Oh man, if it was a night like this would be one of those nights where the veil would actually be stunning. The Veil Nebula. And as you can't really hear it, but I'm racing over to my collection of attachments and so forth, and I'm gonna put on a lens, or not a lens, but an adapter that allows me to see some of those details very, very brightly. Don't worry about the screen, it's not a supernova.
Oh, should I be warning people to watch their eyes?
Yeah, that's what I'm saying, yeah.
Oh.
Sorry. I'm just, I'm actually using that.
No, it hasn't hit for me yet, so I'm just gonna...
Alright. Okay. Alright, here we go. And we'll put this back in. We'll have to refocus on a bright star.
Oh, it's red.
Yeah, because I have a red light on.
Oh, there's the white.
Yeah.
And then as long as it's not bright glaring white, that's okay. Red I can deal with, but no, there's the red. There's the retinas.
Yeah.
Burning.
There's the retina burn. Yeah, sorry about that, guys.
No, I warned them.
Apologies.
If they missed it, it's their own fault.
Well.
Ooh. There is a purpley blue color. That was pretty.
Nice. Okay, now I'm gonna go up to Alberio, our favorite double, and I want to go there because I want to be able to see just how far out of focus it is. Interesting. Not that far. Not that far. In. Yeah, this is beautiful tonight. Oh, look how beautiful Alberio looks tonight, guys. This is gorgeous. This is our first double star stop tonight. Alberio is actually a stunning double that's in a tremendous position to be viewed tonight because the sky is so nice. Oh wow, okay. Now let me I remember we talked about this before, you know, Alberio is 430 light years away, and those two stars are separated by 4,620 astronomical units, so they're not close by any stretch, okay? But remember, Neptune is 30 astronomical units from our sun, and those are several thousand more. So that's pretty interesting to note that, and especially the distance of 430 light years. And you know, by now some of you may know that the star on the right, which is artificially blue because of the filter I'm using, that star is actually a K3 giant. All right. And the other star, if you recall, what is it, Amanda? Come on.
I don't know, because I was going to get the wrong...
Well, say the other one. If this is a K3, well, the other one is... I don't know. Correct. It's a B8. Very well. She didn't say that. That's homage to the fact that nobody could hear you the other night on the stream, and that was only I could hear you, so... Alright. So, again, now that we saw this, I'm going to go to...
Because the blue one, when you were saying it was blue, I was thinking it was got to be an A. Well, not it has to, but I was thinking A, and then when you said K, I was thinking that's further down.
Right.
Than I thought. So that's why I was trying to think, like, the other one... I don't know.
That's alright.
I don't know. I would have been wrong on both counts.
Nah,
let's put it that way.
You would have been okay. Okay.
But now, yeah, the distance and like the distance between them and from how far they are to us and stuff.
Yeah.
That's why it looks closer than they actually are, just because they're so far away. Things like that are still really hard for me to get my head around because Daryl was trying to explain the solar flare that happened the other day. I'm hoping maybe you can touch on that too.
Okay.
And he was saying the sunspots were bigger than the entire planet of Earth. And well, that's to correct. Me is just stupefying. And
well, again,
can you talk a little more about that maybe for us?
Sure. Well, I'm taking this 25 second exposure at ISO 20,000 of the Veil, a remnant, supernova remnant. I can, because it turns out that when we look at the way the sun is made up and the way that the sun's features show up to us, they're at a scale that is commensurate with the size of the sun. So sunspots are small on the sun, but compared to us, they're huge. Just like to us, you know, clouds are massive. Oh my God! Wow, it is a beautiful night. Sorry, this is stunning. I can't believe it. Looks so beautiful. Anyway, and so, sorry, I'm kind of at a loss now because I'm just like, yeah, okay.
Okay.
So anyway, the truth is,
we love your excitement like to do this all your life. Like you were even looking at these stars and stuff at like 7, 8, 9.
Yeah, I was.
So to see, like, you know what you're looking for, you know where to find it, you know what it's gonna look like, you know all the elements, and you're still so blown away by the pictures. I love it. I love it.
You know, this is like that. This is that magic zone where it's just dark enough to start taking great photos, but the moon isn't up yet. And when the moon comes up, all of this goodness goes away. But that's okay. We still have double stars and we still have clusters. So while we have time, we're going to do these nebula. And that was an executive decision. I apologize for springing it on you last minute. But that's what we're going to do, you know, because I think you'll enjoy it. So going back to the sun is almost 1 million miles across when you think about it. It's 864,000 miles in diameter, and it has large-scale features and small-scale features. Some of the small-scale features are things called granules, and there's granulation on the sun. And wow, this is below the star 52 Cygni. You can still see some of that very, very fine, wispy detail. And I'll get back to this solar granulation in a minute. Look at that. You can see this stuff. This is just beautiful. Wow. So, okay. So then, I'm now going to go to another spot because we have to. I'm going to go to a section of the veil that I haven't been to before. Because when I tried to go there before, we couldn't see anything. It's a little bit fainter. Anyway. So granulation on the sun is like little tiny convection cells like you see in your pot when it's boiling. You know, they break into little cells, and you see the little cells. And these little cells on the sun are very very tiny relative to the sun's overall size, but compared to the Earth, the granules themselves can be fairly large, and maybe a couple granules are the whole diameter of the Earth. So these are massive features compared to us, just like we are massive compared to the ants who are looking at us. It's all about scale, and you know, we're designed to operate at the scale we operate at. We are most efficient at our 4 to 6 to 7 foot range in size. Ants are most efficient with their size, and for their size, for instance, ants can carry a massive amount for their body weight. And we don't have that particular leverage capability that ants do, but you see, that's the kind of thing that we think about. This last one that I didn't think we'd see anything is correct. I didn't see anything, so let me just go where I know we see something. I was in a very faint area, and I probably not quite where it needs to be. Actually, I'm gonna try one more. I'm having a ball, sorry. I'm just having a good time here. So, anyway, so the features we see in the sun then are actually very, are fine for the scale of the sun. They're fine for the scale. And that said, when we look at the features like the prominences on the outside area of the sun, well, guess what? I mean, those prominences can be very, prominences can be very, very large, to the point where, the entire Earth could fit within a loop, a coronal, a streamer, a prominence streamer. That is one of those. Well, we'll call them loops. It's a loop. It's a magnetic loop. It follows the magnetic field of the sun, and we can actually see. When we look at that, we can actually see the Earth inside without any problem. That we can fit the Earth in there. So the features are large, the features are small, but they're all bigger than the Earth. Okay, the Earth is actually very, very small by standards of the Sun. Now you put Jupiter next to the Sun, it's a different story. Jupiter will have a different size compared to the Sun. Jupiter may look like it's more, appropriately sized. You might see a little better. And that right there shows you something about the transit program when we look for exoplanets. If we look at Jupiter and we compare Jupiter's size to the size, say, of some of these exoplanets we're looking for, well, we find that these exoplanets, for instance, will be very, very much, Jupiter size, and they were the easiest ones to find. They were the easiest ones for us to find, and if we didn't look for those, then we might not be able to find any planets. We would assume there were no planets if we couldn't find any. But the truth is that the planets that we see around some of these stars were Jovian-sized planets in the beginning, because that was the easiest to find, like I said. But that technology has improved to the point now where we can actually find planets the size of the Earth around other stars. That actually that corresponds to a major breakthrough in technology and abilities. We didn't have this before, and now we do. So it's all part of the it's part and parcel to the planetary searches. So I'm very pleased with that progress, and again, the scale of the Sun and the scale of its features can also cause a problem. Jeez, I was looking at this part of the veil that we're familiar with, and again, I'm using a filter here. You'll see it in a sec. Whew. I mean, absolute detail is just great. Wow.
I figure it's the one time you were screen sharing on Skype and I could actually see it live to comment. It was the one time they couldn't actually hear me.
Why? What do you mean they couldn't hear you?
On Skype the other night.
Oh, right, and they couldn't hear you.
Because right now I'm seeing the 30-second delay on YouTube with everyone else, but they hear me 30 seconds later.
Yeah.
I would have been right on time with everything when you were screen sharing the other night, but for some reason they couldn't hear me, and
well, you know what?
Ironic.
We're gonna do an experiment right now.
Uh-oh.
All right, I'm gonna share my.
Oh,
screen.
you might want to wait until you have the higher internet speed. I don't want it buffering on people.
Well, let's just wait and see, because now you can see it. So you should have my screen now. You should be able to see it. So Amanda, you'll have the screen, and you'll get to see what I've been talking about. You can also.
Okay, I'm seeing it. I have chat popped out.
Yeah, good. And I don't see any buffering going on now. There we go. Wow, this is beautiful. Okay, so as I was trying to say, I also got to tell you about something that happened earlier tonight. I was sitting in the house having dinner, and all of a sudden, I got hit in my chest with a shockwave and a massive explosion. I mean, so much so that it literally sounded like somebody had actually set off a major explosion, a major bomb. And I had no idea where it came from. Went outside, couldn't see any indication of where it might have come from. And it was extremely unnerving because it vibrated every piece of me, and it vibrated the windows. I mean, it was a true explosion. God, this is beautiful. Holy cow. I gotta do another one of these. Sorry.
Don't stop talking when you're talking about an explosion hitting your chest.
Well, no, but it was something outside, and I don't know what it was. I still don't have the answer. But I do know that there have been some kids that have been setting off fireworks every night over the lake, and they'll do 1 or 2 big giant fireworks, professional-sized fireworks, that are literally about 500 feet from my house over the lake, and then they disappear for the night, and the cops come, nobody's there. But tonight was this massive explosion before it was even dark, But when I say explosion, we've all heard boom. You know, this was an absolute, literally like a World War II bomb landed in your yard, and it shook the house. It made it like an earthquake, basically a mini earthquake. And if we had a seismic oh my God, sorry, if we had a seismic reading out there, we would actually, freeze that screen. I'm gonna go do another one. If we had a seismic reading, we would see that it actually measured on the Richter scale. You know, well, they don't call it a Richter scale, the moment scale, the new scale for earthquakes. It definitely would have registered. It was massive.
Well, I was going to ask if anyone else in the house felt it, but if you said it shook the entire building, the house.
Yeah, the dogs. Wow. The dogs were running for cover. You know, tail between the legs, running for cover, hiding under the tables and chairs. It was just. It felt like an attack. It really did. I mean, I could see what people in World War II, you know, being bombed by the Germans could feel in London, and what the people in Dresden had to think when the Allies were bombing them with fire bombs. You know, that's you know, it's horrible on both sides. And then, you know, that's probably the equivalent sound of wow. Oh man, I'm sorry. I'm just like enjoying the look here. It's the equivalent sound probably of the main detonation of a nuclear bomb. Okay, which is surprisingly, you know, low decibel, but it carries with it very, very high overpressures and stuff like that to cause the damage it causes. And of course, we were the only ones to ever use a nuclear bomb, so that's something we're proud of, right?
Do you think whatever you saw earlier tonight could have been like maybe a drone or something looking for the cause of the explosion?
No, not at all. No, this is I have as you know, I have a fleet of drones here, and I don't none of them, you know, operate like that one. It wouldn't, you know, it was, they have lights that flash, and the flashing lights typically say a number of things. They say, okay, you can see at a glance what the battery life is. You can see at a glance whether it has GPS satellites, and if so, how many, you know, and so forth. And so these are all color-coded lights. You know, when the battery's low, the lights change and they do a different thing. They have a pattern of blinking that's different. Every drone maker has different patterns, but they're all getting standardized. So you would not expect to see a drone that's just sitting up there with a bright white light and then go away. And that could have been these iridium flashers, iridium satellites. And if it was high enough, then it could have actually caught the sun and not appeared to move so fast through the sky, but it probably was moving. I'm just, you know, finding it incredible that this actually happened. I gotta stop on this because you gotta see this. Oh man! Now you see this now, right?
I see it. Yeah.
Yeah. Is that not beautiful? This thing. Look at this. It's like, look at how stunning and look at how detailed the interior of this is. This is live, man. Look at that. This is live. Holy
okay,
cow.
but the Veil Nebula is so big you can't get the full thing in one picture, right? This isn't the entire. Yeah.
The Veil.
So I keep thinking you always have to take it in two separate pictures, like it's on two separate sides. Well, but it's all connected. It's not divided by like the Milky Way or anything.
No, it's got a gulf of space between it because the progenitor star, the star that they actually caused it, is you know, the remnant is in the center somewhere. And usually they leave behind a pulsar or a neutron star, or sometimes a black hole is formed. You know, what they never leave behind is a white dwarf. Supernovas don't leave behind white dwarfs. White dwarfs are the dying realm of stars that are more like our sun, and a slightly bit more massive. Above a certain mass, then, you know, the typical end result is going to be an explosive end, a major explosive end, and that's something that we don't have to worry about at our end. We have to worry about the slow death of a star bloating into a red giant as it uses up its hydrogen. Oh, there's some fireworks. Anyway, go ahead. You were saying.
So is it dependent on the mass or the elements that determine, like, when it dies, whether it becomes a black hole or a...
No, the first thing you said is what it is. It's the mass.
It's the mass, okay.
Yep. We have, by the way, I just want to let you know, we actually have some clouds that are forming, and they're forming dynamically. It's actually what happens when the relatively warm ground begins to cool at night. You end up getting this cooling process that happens, and it actually makes clouds at altitude. So I'm hoping that they drift away from us. I mean, they're going away from us, but the formation rate is drifting toward us. The formation, the forming cloud pattern is appearing more and more toward us, but it's actually drifting in the opposite direction, which I think is pretty interesting.
Okay, we have a few questions coming in.
Sure.
Lacey wants to know if you know anything about the Snow Lab in Sudbury, Ontario. Because I'm not sure if that's an observatory. She thinks it might be a physics lab, that Stephen Hawking goes there every year or so. Huh. Do you know? That's where she is, out in Sudbury.
Oh, wow. That's in Sudbury?
She was from Nova Scotia and moved out to Ontario, which is the opposite of me. Isn't that weird?
Yeah.
And she's a Sailor Moon fan. Yay!
Wow. I do not know about the lab. I mean, I know about a number of labs in the United States, but I don't know about any in really Ontario.
In Canada, no.
Yeah, no.
Because Mario actually asked if you'd ever been to the Palermo Observatory.
Palomar?
Yeah.
I have not been to Palomar. I actually used a telescope for my thesis work that was actually more akin to the size of the 48-inch Schmidt telescope at Palomar, but I didn't use that particular telescope. There was a lot of stuff that a lot of equipment I've used. I think I told you the story, and everybody else, that I was in the observatory for the 20-inch refractor at my university, and this 20-inch refractor was a telescope that was around 30 or 40 feet long, and it was so big that when you moved it, you had to move it electronically, of course, because you couldn't move it by hand. And when you moved it, you actually had to move the floor up and down to meet the telescope eyepiece. And that my fateful encounter with that telescope almost abruptly ended my career, because there were these large safety railings around the central pier of the telescope, and they're big steel bars. And I raised the floor, but I had the telescope in a position that was actually forbidden, verboten, nunca, don't ever put it in this position. And I did. I put it there because I was tired. It was like 4 in the morning. I couldn't really see, and it was very tiring for me. So I ended up doing that. And by the way, folks, I'm taking pictures over and over because I'm gonna put these RAWs up on the SkyTour LiveStream site, and then I'm going to process them. This is very, very successful imagery for this right now, and I just don't like this bank of clouds that formed out of nothing. There was nothing in the sky, and then they formed. So it's the post-cooling clouds that occur that you see sometimes show up out of nowhere. They're evil monster things, and they know I'm doing this, so they're saying, okay, we're going to come out now. So anyway, I actually, when I brought the floor up to meet the telescope, I heard the elevator, now the floor, by the way, was probably 60 feet across. No, not 60, about 45 to 50 feet across diameter, okay? And when I was raising the floor, all of a sudden I heard, and then I heard, this really ghastly noise, and I started to run from the console because I was thinking about horror movies and stuff like that, and I just, like, my instinct to preserve myself and not get eaten by a vampire or whatever made me run, and that's when I saw it. I saw the railing bending, and I couldn't see what was bending it. So my first thought, and I told you, the story with the abridged version, but I couldn't see what was bending the railing because the telescope piece that was actually hitting it was painted black. All right, so in the darkness, it looked like the railing was bending on its own, and it was literally the most frightening thing I had ever seen. Of course, without knowing what it was. Once I figured out what it was, I realized it's frightening for another reason. It was going to get me, canned from the program. But as it was bending, it was making that steel rending sound. And it's like, what the heck? And then I heard the entire building shake because of the elevator. The elevator was a big wooden circular floor, like I said, 40 or 50 feet in diameter, and the whole thing moved up and down to meet the telescope. So that's how this was. So, and I had the telescope pretty high. I had the floor pretty high. So it was just a nightmare. And when I came in the morning to see what happened, I saw that the telescope was absolutely unharmed, which was like, I didn't sleep all night. I was supposed to go home and sleep until noon and come in. I didn't. I stayed until I could see. I didn't even go to bed. And I basically went out, got some quick breakfast, came back to check out my handiwork, and discovered that the telescope was perfectly fine, and I was just so happy. But then I still had to explain the giant dented pole, the giant dented safety rail. And so I did. I said, "Oh wow, I don't know how that happened." And they knew I was the one in the observatory, and the team lead for the project said, you can just say that you screwed it up. And I was like, I screwed it up. And he explained to me, he said, you're not supposed to put the telescope in this position. You're not supposed to. I go, I know. But it was 4 in the morning. I was extremely tired. And I just wasn't thinking. And he goes, come with me. And I thought he was going to escort me out of the building. I really did. He had that look in his face, like, you're dead, kind of a thing. He goes, come with me. And he brings me into the other dome with the larger with the Schmidt-Cassegrain telescope that's a larger diameter, but heavier, more of a monster in the other dome. And he showed me a dented railing in there. And I said, I didn't do that. He goes, I know. He goes, I did.
Nah.
I went, oh, you did. And suddenly I felt like I'm not going to get fired because he's helping me, Oh my God. Sorry. I apologize, folks. I'm taking imagery of the Dumbbell Nebula unlike we have ever seen it before. Wow. Oh.
It's all blue over at the sides. It's not as sharp of a dumbbell image or hourglass image.
Well, because of the fact that I'm taking such a deep photo, we're actually catching a lot of additional detail. And the nice thing is, just like an image that's called an HDR image, I can actually reduce that and see the inside of that very well. This is very, very nice. Very nice. It's 25 seconds, by the way, at 20,000 ISO. And because I'm using the special filter, this special filter is knocking down some of the light that might get to the camera sensor, so I'm increasing the exposure by an amount commensurate with this requirement here. So when you're saying now, see that blue is the sky, okay? And then when you look at the central part, there's blue in the central part. You'll see in a moment here, guys. That image you're looking at is just freaking stunning. It's nice because the Dumbbell Nebula, when I was a kid, when we looked at the dumbbell, we only saw the hourglass part, and in our best photos we only saw this little hourglass shape. We never saw the rest of the story. We never saw the rest of that gaseous nebula. Now, before you ask, I'll tell you, it really was there. Okay, it wasn't something that just showed up one day or accumulated over time. From our point of view, we actually saw that in larger, deeper photos of the dumbbell. Remember, the dumbbell nebula, okay, is it's literally 1,400 light years away. It's a massive nebula. It's several light years across. And it's one of the brighter ones, but it's also one that has a lot of detail in it that can be discerned really nicely. Oh, that's gorgeous. I've never ever taken a photo of the dumbbell that looked this nice. This is a first for me. Just like with the veil. Man, I hope the moon forgets to come up tonight. I mean, this is just beautiful.
Yeah, because you keep saying it's going to be washed out because the moon is full.
Well, it's after
but
full.
It's not totally full. Wasn't it full, like totally full on the 6th? And it's now starting to wane? Yeah,
it's on the waning side. So, next week I'm leaving for Devil's Tower to speak at that conference on Wednesday. And I'll be there through Monday. And on Friday, I'm going to lead a Skywatch. And that Skywatch is going to be out at Devil's Tower National Monument, right at the base of the tower. And it's going to be an amazing, absolutely amazing night if it's clear. And it looks like the weather is showing that it might be clear out there. And the nice thing is, out at that point in Wyoming, there's absolutely no light pollution. Okay, there is some, but there's absolutely no light pollution in the area that we're going to be observing from, and it's going to be, it's going to be just beautiful. And in fact, I get a little nervous because, under really, really intense skies, I can actually lose my bearings. I'm used to the sky for years and years and years. Yet I can forget where things are because there's so many more stars than I'm used to seeing. Absolutely incredible. This song sounds like a puppy dog commercial. Give your puppy the best for him. Purina Puppy Chow for you and your little guy. That's what it sounds like to me.
Well, I noticed there was another one on earlier. I hear at Keith's all the time.
Yeah,
at P&K Space Imaging. For anyone in chat that isn't joined already, please subscribe. I'll put the link in momentarily. Yeah, there was one he plays all the time, and it reminds me of this really bad one-hit wonder song from the 90s, If You Steal My Sunshine, by Len. And I swear, if I started singing the lyrics, it would go perfectly to the beat. And it just... those songs that and you like, and they seem so much flatter than the rest.
You have to understand that people that create these songs for YouTube probably had inspiration, and they probably borrowed some of the melody lines from some existing music, not borrowed as in stole, but recreated them for their songs. Like I could tell you this: there's one that Keith plays over on P&K Space Imaging all the time, which is. It sounds just like Joe Satriani, and Joe Satriani is this amazing guitarist, okay? And this song you're hearing now is one you hear at P&K quite often. Now, the reason is I'm playing a different set of music tonight. I'm playing the more bouncy tunes. And normally he plays these without any kind of voice in the background. So we'll see what happens. We'll see if people think that this is a lousy thing or a good thing. I just thought it was good for some variation, Plus, it'll keep me awake, man. Woo, yeah. And especially in a night like this, before the moon comes up. Oh, man. Having a good time already, and I can't believe just how beautiful this is tonight. It's almost like, see, we have something, the transparency is really high tonight, and the seeing is good. And so, those are the two factors that astronomers care a lot about. And I'm just going to take one more of the dumbbell nebula here, and then we'll move on. Oh, you know what I want to do? Ooh. Before the moon comes up. And it sounds like a song. Before the moon comes up.
Mm-hmm.
We'll be back. We'll be right back. I'm going to find and photograph another nebula before we lose it. I think it's going to be fairly high in the sky.
We did have a request for a sighting coming in.
Okay.
Was it... Hold on. Yeah, Ronald wants to know if we can see M51.
The whirlpool is actually kind of low right now. I would love to look at the whirlpool. It'd probably be beautiful tonight. But
will it be up later, or will the moon be interfering by then?
Yeah, the moon will be interfering by then, but it never really sets, but it's going to be down below the polar, the North Pole, and so it's going to end up looking rather washed out. Okay. All right, we're moving now.
And when you were telling, and I had to warn them in chat because
yep.
I do have the 30-second advantage. I said, pay attention, guys. You don't want to miss this story about the telescope and the warping pipe.
Oh, yeah.
And I was trying to restrain myself, and I asked Daryl, I said, because he could feel the panic. He said he would be freaking out as well. Only I think he used the phrase pooping kittens. If that happened to him. And I said, did you hear the other one about you smashing it into the windows or computers or whatever it was? And he said no. I tried to refrain. I didn't want to be too off base. I wanted to focus on the nebulas and double stars and stuff, but could you please tell us that story? Because I bet a lot of people in here haven't heard it, and it's so funny. I'm sorry. It was terrible. It's a tragic story, but...
Which story are you talking about now? Because...
The one where you smashed the telescope into... I don't know, it was like $10,000 worth of something. I don't know if it was glass, if it was computer screens.
Oh, I actually... That was in that dome where the professor, partner guy was telling me that he bent that bar. Well, what it didn't say was that was the one where I was encased by the telescope as it actually... the telescope actually, it was moving, and I was moving it, and I was sitting on a very tall ladder to reach the eyepiece. All right, and the problem was that this telescope actually ended up, hitting the ladder and started to compress the ladder around me while I was sitting in this ladder way at the top, and and what happened was I was sitting, I wasn't touching any controls, and the telescope was moving by itself. And the reason it was moving by itself is because it's a hand controller I had sitting at the top of the ladder with me, and I was accidentally sitting on part of it, and it made it start moving. And then before I could figure out where it was moving and why, it was crushing the ladder around me, encasing me in steel. And I thought I was going to be killed by this thing. I thought, oh man, I'm going to die in this dome. They're going to find my body all mangled in this dome. But I don't know if that's the story, but you were talking about. That's the one I remember that I told you about at one point.
No, I know you have a lot of stories like this, but no, there was another one, and I'm sure there were a whole bunch of... I don't know if they were professors and you were in school at the time, or... I think you were visiting a lab and didn't maybe have the proper authority to be there, and you smashed the telescope into something, and it was like worth like $10,000 worth of something, and you thought you were going to be fired or expelled or something. I can't remember where it was though.
You sure it was a telescope?
What else have you smashed into $10,000 worth of camera equipment or?
Well, you have that number 10,000. Like you know what's funny is I don't remember that in particular. But you know what I do remember is I remember working at the movie studio with Doug Trumbull on my first day. Remember that?
Yeah, that was the garage.
That was the garage where I blew the hole in the garage door without, thinking I'm gonna be so fired.
Oreo flinger.
Yeah, or the Oreo cookie flinger. Okay, so it wasn't that.
It was something you were moving, and I don't know if it was automatic or you sat back on a controller that started moving it or something.
Well, that's...
It was besides something. It was besides something, and you took out other equipment with it. You smashed glass screens or something.
Yeah, I remember that. Yeah, that was actually the that dome I was telling you about, and it was that incident I was telling you about where the cage, the steel cage that was around me, was getting cracked and bent around me because the telescope was just literally pinning me into the cage, and I couldn't figure out how to get out of it. And of course, I did have there was no computer screens in there, but I did have I did have a couple lenses and so forth with me that were in my lap, and I figured those were going to get crushed along with me. But I don't know if that's what we're talking about.
No.
Yeah, I'll remember it. I mean, there's so many things that have happened to me over the years that.
Yeah, because I'm sure there were people around saying, "Who is this guy?" And you figured you'd never be allowed back in there again.
Okay.
But you were. It was another one. I don't know how you can damage so much stuff and still be invited back.
Oh wow!
I mean, seriously, there's a lot of these stories, and you know.
I just want to.
That's the price you pay when you work with Mark D'Antonio.
I'm afraid so.
Stuff gets damaged.
Well, not intentionally, of course.
No, of course not.
This, by the way, what we're looking at, this is called the Iris Nebula. This is actually a bright blue nebula. And that star you're seeing in the middle there is a star that's not hot enough to make this dust glow, or this gas glow, like hydrogen gas can glow, which we see as orange, like in the Lagoon Nebula, and in the Eagle, okay, and the Omega. That's not this. The Iris is actually a lot of dark nebula, which you can actually see some of right above the star. You can actually see some of that dark nebula, okay, right there at the top of the star, okay, up there. That little, what looks like an artifact, is actually an actual, it's an actual feature of this nebula. And there's dark nebula, dark gas, and you're seeing this bluish reflection because the star, like I said, can't excite this enough. Can't excite it to the point where it will actually ionize and cause this. So basically, we're actually watching, we're seeing the reflection nebula, okay, as opposed to an emission nebula. This is a reflection nebula. All right, so, and this here is approximately 1,400 light years away, and it's really quite a beautiful photo of it. And I'm gonna do one more, and then we'll move on. Wow. And I'm keeping an eye out for the moon. See where the moon is. And you know, another thing that's out right now. Oh, I'm seeing some moon glow. Arg. This song, by the way, is called it's the Can Can. This is actually.
Are you allowed to use that?
Yeah.
Cool.
Yep.
I was gonna say I liked it right from the beginning. It's not the part. Oh, does that mean you're gonna break into a rendition of the Element song?
Well, yes and no. I'm gonna. This song was actually the one that was used for the Element song, and I always thought it was a really. It was very nice because this particular song, or the song actually was really. Oh, I don't know. It was perfect for the Element song. And for those of you that know what I'm talking about the song that is the periodic table of the elements song. And it went on and on and on. So there's hydrogen and helium and lithium, beryllium, you know, and it just goes on and on. But this song was used for that, and the guys that did it are just great. So I always pay them homage, give them credit for it because it was really well done.
That's not even the first version I heard.
No, there was another version that's not nearly as exciting. I think that other one is okay, but I like this one better. I like the Element song with the Can Can. It's much better. Just my feeling.
Yeah, well, yeah, of course. People will be probably drawn to the first one they heard, but...
Well, I listened to all of them. I mean, over time, I've listened to all of them.
Oh, I only heard... I only heard the two.
Yeah.
Like they're like the other one isn't the can. Yeah. But obviously it's the same words, just...
Yeah.
Well, not really. I don't think... Because in the version you sing, the can version, it says something like, fluoride for your pretty teeth.
Yes.
Like, I don't think they have lyrics like that. I think they're just the elements. I'm not sure if there's little clues and stuff along the way, for lack of a better word.
Yeah, maybe.
Like, what's fluoride? Fluoride's for your teeth, you know? Like,
I think you're right. I think this is not... This one was probably, you know, better that way, because it was a little more descriptive. Right.
Someone said that Paul is streaming.
Okay.
I don't want to detour from the channel, but if it's P and K, our friends, for those that watch P and K Space Imaging, the P in P.
Yeah.
The P in P and K is Paul.
That's right.
And he's down in Miami, where the hurricane is heading. And he said, for some reason he's staying, and he said he may possibly stream tonight. Now, someone just popped in, Rocketman popped in, and said, have you seen what Paul's been doing? I haven't, nor do I see him streaming.
Okay. Well, maybe he was asking a question. He was asking a question.
He says, do you see what Paul's been doing? And I said, is Paul live? He says, yes.
Oh. Okay, I can't see, so.
He's in the hurricane. Do you know why no one can see? Okay, I don't know. I don't see him.
Okay. I'm over on the Eagle Nebula now, by the way. I'm taking advantage of my non-moonlit sky time. Let's see what we get.
Yeah. He's live. It looks like a parking lot.
Oh, that's probably the top of the parking garage.
Yes, yeah. Sorry, I don't want to distract from your channel, but
no, that's fine. We're all together on this. Paul and Keith
I know, but I am
Skywatcher and I. We're all together. AstroImagingLive.com is our website, and we actually have all of our streams up there. Oh my God! Did you see that? Oh, wow! This is, oh, wow.
What is this?
This is the Pillars of Creation. It's stunning. Oh, I'm doing this again. Holy cow! I hit a magic button tonight. I'll tell you that. This is beautiful, guys. This is like, oh, it's so stunning. It's like you don't even have to work to try and see these things. That they just like explode out of the screen at your face and say, "Look at me! Hi, I'm the Pillars of Creation." Bam, bam, bam. You see all three of them like nothing. Oh man! Wow. Sorry for my exclamations. I'm trying to be a little bit more circumspect, but it's very difficult when you have something that looks so absolutely beautiful. Wow. And all this because, you know what, this all happened because tonight as I was walking around the telescope, I whacked my head on the telescope because it was over my head, and I moved it. So I had to realign it. And I got out the wrenches and stuff and got myself all realigned. And I did it in 10 minutes, thinking, all right, hopefully it works. And it was perfect, because this is dead center. Oh, man. I'm, you know what, if I was cold, it's gone. Wow. This is just so beautiful. I gotta, once it comes in, I'm gonna actually zoom in to check it out a little more. Oh man.
We have a question from Mario.
Sure. Okay.
It's kind of long. Hold on a sec. It says, "How does the telescope tracking affect the shots, or does the stacking take care of the alignment?"
Oh, that's a good question.
In other words, does he have enough time to shoot 15 to 20 second shots before the telescope tracks?
Well, the telescope's tracking continuously, Mario. So, and thanks for the question, Mario, because you know what, that is sort of a black box that you know, some people may not understand. So I appreciate that very much. The telescope is actually tracking 100% of the time. So right now it's actually following M16, the Eagle Nebula, right now as I'm shooting it, and I'm doing a 25-second shot. Now at this magnification, a 1-second shot would show a slight blur. 25-second shot, it would be just streaks. It wouldn't really be very good at all. But because we're going because we're actually doing this using a tracking system on top of a steel pier. The steel pier is taking care of all. This is so beautiful. The steel pier is taking care of all of the stability issues because, of course, I installed it perfectly level, and I had it actually set up so that I could mount it and point it at the North Star easily. Here we go. To the right. Now see, they changed it a little bit. Iron is at 26. It moves too fast for me to actually sing it at the speed that this song's going. Halogens and alkali react explosively. Stereo will see new. Just when electrons are added, moving to the right. It goes on and on. I love it. One of these days I will sing it, and you will never come back to my channel again, folks. I'm sure that's the way it's going to be. So it's, yeah, I'll try.
I can just see your little legs going.
See this part right here? You got to race through the higher radioactive ones, americium, nobelium, lawrencium. I mean, it's like you can't speak fast enough for that, Then we're done. Oh yeah, really good.
Sounds like something Stephen Fry would have come up with.
Don't you think?
Yeah.
Yeah. So, I was going to take can and move it out of there, but then I said, you know what, I'm going to leave it in there because it has some pertinence. I like it. Wow. Wow. Yeah, okay, so... yeah, I don't know.
Ronald says, where is that cluster in relation to the red cloud?
Oh, it's actually the cluster we're seeing on the screen.
I would assume, yeah.
Okay, well...
It just came in.
Yeah, well, it went, yes, I know it went away, but...
No, the question just came in, so I don't think...
Okay.
It wasn't from, like, 20 minutes ago that we moved since, Yeah.
Well, keep in mind that this whole collective that we're seeing, the nebula and the associated clouds, are literally 5,700 light years away. So it's actually... it's fairly distant. It's 35 by 28 arc minutes in size, and those who remember can actually calculate using that special 206265 number that I gave you years back, it seems like. And you can actually figure out how big this is in light years in the sky. But the cluster and the nebula is 5,700 light years away, roughly. And I say roughly because it's hard to know exact distance for some of the features. But you can actually see the nebular detail very, very easily. And those three pillars that you saw in the center there, those were the subject of the Hubble Pillars of Creation image, and they really, really, really are showing so beautifully tonight. And let me tell you this: when I get this telescope to Arizona, what we're seeing now is child's play compared to what we can do when we're out there. Once it's out there, it's like the sky will be the limit. I'll never sleep. I know I won't. I can tell you right now, I will not sleep. I'll be out there doing this all the time because I'm just that kind of a nut. Wow. Anyway.
I was gonna say, you were commenting earlier you played bouncy music to keep you up and pumped. Even with the nice, calm, melodic music, you have to pull yourself away at like 2 in the morning, so...
I know, who am I kidding?
Yeah.
Who am I kidding? But winter is approaching, So, you know, bouncy music is better for me to keep me awake and keep me on top of my game so that I'm not lethargic and talking slow because the cold is slowly eating away at my, you know, layers of protection. You know.
Some of these stunning pictures are bringing you back to reality pretty quickly.
Oh, you know what? As soon as you see one, like, wow, that's great. You look at that and you see this picture and you go, wow. You can see all three. You got, you know, at the top, in the middle, and at the bottom. You got all three of those pillars of creation. And then you got a little added bonus down at the bottom. Okay, right down here, you actually have some more detail that's visible as well. And you know, it's just wow. I can't wait to process these. It's like I can't wait to process them. It's like, okay, I won't be going to bed. When I get in, I'll be nice and warm, and look out, world, I'm going to do this. Now, one should say, well, if you're going to do this, shouldn't you do the Trifid Nebula and the Lagoon? You bet your butt I should. So I may very well.
It's awful clever of us to mention that.
Oh, you mentioned it?
No. You said before you guys suggest
I'm
doing this, and I thought, yeah, that's very clever of us.
No, but that was very good.
Put that suggestion out.
That was very good of you to suggest, but not suggest, yet suggested.
Blame us if you need a reason. If you get yelled at while you're out all night, say, chat wanted me to do the Trifid in the Lagoon.
Hey, listen, I am happy to blame you for beautiful, beautiful shots. Beautiful imagery.
Throw us right under that bus.
Yeah, I will blame you for it easily.
What now? Do you know why it was called the Pillars of Creation?
Well, certainly there's reasons for all the naming conventions, and the Pillars of Creation, the reason they call it that is because you're seeing these three molecular clouds, and these molecular clouds are made of, you know, and composed of basically building blocks of life, and the materials from which the Earth was made, the materials from which we were made. And so basically they're like the pillars of creation. That is, they are harboring stars in formation that haven't winked on yet. And so that said, these are going to be basically a storehouse of material for future stars and potentially future planets. And who knows? You know, perhaps a billion years from now or more, there will be a planetary system there, and a planetary system that would support life at some point.
Well,
you know?
See, now that's kind of what I thought you were going to say, because that makes sense.
Yeah.
And that would have been my guess, just hearing the name and taking a guess. But would they not have discovered this and not known what it was in the first place? And then later on discovered what elements were part of it. So how could they have known it would have the kind of elements that provide life?
Well, I mean,
you know, you're seeing things in the sky and you're not sure what they are until you study them, like Messier objects.
Yeah.
It's not a comet, but I don't know what it is.
Yeah, no, see, the thing is, are you talking about us discovering them?
Yeah, whoever discovered the Pillars of Creation, like, did it have another name before, or like, how did they know whatever this was must have the elements that provide life?
Well, it was always called the Eagle Nebula, M16. You know, so so it was always called that. Okay, I'm gonna go to the Trifid now.
Okay, that makes more sense. So if it was a Messier object called the Eagle, and then we went back and looked and found... Okay, that makes a lot more sense. Okay. That's cool.
Nice. Alright, here we go.
See, that's why, I mean... I don't know.
I know. You do
when
know.
you look at what these things are, and what they contain, and what they could mean for the future, and what they point out from the past... You know, names kind of become, oh, that's interesting, you know, but you're more interested in the other stuff. I think I think knowing the meaning behind the names are so much more helpful because...
Yeah.
No, story.
I don't disagree.
As...
Are you there?
I'm here.
Okay, I couldn't hear you for some reason.
No, the music gets louder from time to time, sorry.
Huh. Well, I didn't think it did. I apologize. Alright, let's just do a quick exposure of this right here.
John wants to know, how dense is the material of the pillars?
See, that's what's interesting, okay? When you look at the density of this material, you find that it's actually not very dense, okay? There's a lot of space. There's a lot of space around this, around each atom in this material. So that's what's interesting about the pillars of creation and the trifid and the lagoon. And we don't have the same, we don't have the same kind of densities like we do for molecules in our air. You might only have say 10,000 atoms per cubic meter, whereas in other places you might have, like on the Earth, you've got millions of atoms, okay, in the same amount of space. So we have to consider that space, it's vast, of course, but the densities are very, very different. We don't have the same densities like we do in a nebula. A nebula is very much different, much less dense. But it's okay. It's okay. I'm gonna take a quick 8-second shot here, acquisition shot. Okay, let's move over. Okay, and now we're gonna do a shot of the trifid at the same, like that, and we're gonna go to 25 seconds like before. See, now music like this, for instance, is definitely borrowed from some heavy metal rockers,
I was just looking for the guitar emoji.
See, because I play electric guitar, and I like Joe Satriani a lot because his style is just unbelievable. I guess when you start playing instruments, you just want to add and keep adding instruments. So I started with drums in the 80s, and got good with the drums. I did some, studio songs for folks. Oh,
how am I not knowing this?
Oh, I'm sorry. I actually mentioned it to you because I mentioned that Ringo.
Studio track.
Yeah, Ringo Starr was a very, very important person to me as I was doing. Oh my God, this is beautiful. Ringo Starr was an amazing drummer, and he was never off. He was always on. He was never ever off, and that's something about Ringo that I absolutely admired. No, but I learned to play drums, and I took lessons from a guy named Chris Wink, like Wink Your Eye. And Chris went on to found another group, which I'm sure everybody in the chat's heard of. It's called Blue Man Group. And Chris was my teacher for 3 years, and I learned a great deal from him. And I
knew that.
Yeah.
I knew that, and I was gonna ask you who your favorite musician again was. Who's kind of like a stomp kinda.
Yes.
Was it Ed something or?
Well, Okay, I know what you're confusing the story with I actually took lessons from one of the jazz and blues greats, a guy named Ed Blackwell. And Ed was a guy in his house in the same town where I was, the university, and I went to the house for the first lesson with Ed Blackwell. And I was told, you know, by Chris, you got to have a lesson with Ed Blackwell. You got to start lessons with this guy. I'm like, why? I mean, who is he? And Chris looked at me like, go to the music store and just look him up. You'll find him, okay? So I was like, all right, whatever. So I went to the house to see Ed Blackwell. And when I got to the house, I tried to knock on the door, but there was no door. It was actually kind of off the hinges, and I was afraid to knock on it because it might fall off. It kind of was like just wedged against the house. So I kind of said, hello, Mr. Blackwell. And there was this long, very lean lump lying on a couch way in the other room, and it was him, and he was sleeping with his back to the door, and all around him were boxes and boxes and boxes of medical supplies. So the guy had some health issues, and he gets up and he goes, who are you? I went, I'm sorry, I'm supposed to have a lesson with you. I was going to start lessons with you, Mr. Blackwell. And he goes, oh, you're Wing's student. Yeah, that's right. Oh, come on in, I'm sorry. Total change of character. And this guy gets up and he has arthritis in his hands. They're all knurled and bent, and he can't really open his fingers too well. He actually uses his other hand to spread his fingers to grab some things. And I thought to myself, okay, you know, I don't know what this guy can possibly show me. I mean, come on. He can barely even hold his hands. How's he going to hold drumsticks? And he looked at me and he goes, almost as if he was reading my mind, he says, give me that duct tape. And I get the duct tape. He goes, cut me a piece, 3 inches long. I said, okay, 3 inches, 3 inches. All right, wrap it right here, and he wrap it on his hand, and then he puts it around his fingers, and he slides the sticks in there on each hand. And I'm like thinking to myself, seriously? I mean, what am I going to hear? You know, I can't expect anything good from this. And in my mind, I remember I'm a young, impetuous college student. And then the guy sits down, and then all of a sudden there's a change. I mean, a major change. The demeanor changes. I mean, he has a grizzled face, you know, grizzled hair sticking, you know, unshaven shirt tails sticking out, you know, sandals on, you know. And I'm thinking, what can this guy show me? And it's like, you know, again, I'm full of myself at this point, right? Because I'm thinking even I can play better than this guy, I'm sure. And I got so put in my place within the next 30 seconds, I could not believe it. And I had a whole new respect. And a whole new respect for the, you know, you can't judge a book by its cover thing. And it's just beautiful. Oh, wow. Trippin' Nebula's beautiful. Well, anyway, I sat there in stunned amazement. I literally found myself not breathing at one point, and I thought I was going to pass out because I realized I stopped breathing because I wanted to hear everything, and my breathing was actually too noisy for me. Even though this guy's playing the drums, okay, the rhythm of my breathing was interfering with me being able to hear. It's the rhythm of my breathing. And I couldn't match my breathing to the rhythm of his playing. So I stopped breathing. And he looks up at me. He goes, you all right? You know, and I go, yeah, I'm fine. And I kind of leaned back against his wall, okay? And I was like, wow. And he smiles. The first time I saw the guy smile, and he says, you like what you hear? I go, Mr. Blackwell, I am stunned. He goes, yeah, well, this old man can play, something like that. And he basically was playing everything but the drums. He was hitting the stands. He was hitting the edges of the cymbals. He was hitting his lap. He was hitting the rims of the snare. He was hitting the sides of the drums. In other words, all the stuff making clackety clackety clack sounds. None of the and like boom boom boom. Where were the drums? There were no drum sounds. He was just playing like when you see the show Stomp. He was taking existing objects that can make a sound and utilizing that. Wow, it changed my life. That one visit, that first time I visited with him, changed my life. I listened to that man play, and I left there a changed person. every step I took, I was hearing rhythms. Everything I heard, I would make a rhythm out of it. I'd open the door in rhythm. Open the door. You know, and everything I was doing was in a rhythm. I'd find rhythm everywhere I looked. And I realized after about 6 months of doing that everywhere I went, that it was really, really easy. You just fall right into it. It's amazing. It's so good. So anyway, I ended up really beginning and becoming a real huge admirer of this guy. And so I went down to a music store at one point, and I said, "You guys got anything by this guy Ed Blackwell?" And the guy said, "Yeah, come with me." He already knew who he was. I figured, okay, that's good, you know, because I already had a lesson with this guy, and he was sort of, you know, grizzled and old. And the guy walks over to a whole section. He says, "Yeah, this is all Ed." I go, what? This is all him? Yeah, this is him when he was with these guys. This is him with these guys. This is him alone. This is his solo album. This is this. It's like, wow. And this is the one. This is his. This is the one that he took. What was it? When he played for the Queen or whatever, some kind of, you know, some absolutely outrageous but amazing, you know, thing. And it's like, wow, that's crazy. So, listening to Ed play everything but drums hooked me, and that's when I went back to talk to Chris Wink, and I said to Chris, he played everything but drums. I mean, he played the drums at the end. And Chris's face lit up with a smile. He's like, "Yeah, is that something? The guy's amazing." I go, "I didn't think he could do it." He goes, "I know." He's all hands all bent up. I go, "I know." You know, we talked about it. I said, "I gotta come back to him." He goes, "You bet your butt you do, because that guy will tell you, you'll learn things you didn't even know about how the drums can sound." And sure enough, you know, drums, they have a skin, right? You hit the drum, bum bum bum, makes a noise, right? Well, guess what? If you actually place your finger on the skin and press it and hit the drum, you can get you can get the different sounds. You can change that tonality. Well, okay, I learned all about that. And it wasn't the finger, it was the other stick. You press it down and you go do dee do dee dee do dee dee, you know, just incredible stuff. It was all automatic. After a while, it just became automatic. Oh, I should say automagic, because that's really what it was with him. It was automagic. Anyway, that's a little story about that with the drum stuff. And I just thought that was kind of cool. Oh, man.
Okay, well then back to stars.
Yes.
Ronald wants to know what the green in the trifid is. Or is it actually green we're seeing, or just like a...
You're looking at a blue reflection nebula that's up at the northern part of the trifid. We got the regular singly ionized hydrogen. It's called H2, remember, because H1 is normal, non-ionized. It's, you know, zero charge. But when it's got a net charge of +1, that's singly ionized, and that's where the electron has been plopped off. It's just basically the proton. That's actually that blue that you're seeing at the top there is actually that second star. I'm going to move the star up so you can see it. At the top here, that's a blue. Now, you're also seeing a blue all around here, all around the image. And that blue you're seeing, that's actually an artifact of the filter I'm using. And if that's the blue you're talking about, then that I understand. But the blue is actually the result of the filter interfering a little bit, unfortunately. Now, you might have guessed by now that I'm going to want to do this. I'm going to go down to the Lagoon Nebula again before we lose everything here and have to. I don't want to lose the night with the moon in the way, you know. And speaking of that, because it looks like it's getting a little bright, I'm going to go check if we have the moon up. This might be the last thing we can do. Yeah, here's the moon. Okay. I kind of noticed that the sky was getting brighter and brighter and brighter. So, but we're as far away from the moon as we can be right now. So that's good. So I'm gonna just do a quick 8-second acquisition frame to see what we get. Just to see what we get. That's really pretty. Oh. Like, you know what? I gotta tell you guys, even with the moon out, okay, and it's not fully interfering with us yet, but look at the detail. Wow, this is just incredible. Okay, we're gonna move that over, and we're gonna try and get a little bit more out of this. See, there's a... Oh, sorry. I did another 8-second shot. I wanted to do a I may actually have to go less than 25 seconds because we're actually... The sky is bright, but the nebula is also bright. So 8 seconds is giving us quite a lot. Maybe I can just jump up to... I could actually try something else. Let's try going to 15 seconds at this ISO of 20,000. Are there any questions, Amanda?
Not as of yet. They're all talking about drums.
Oh, okay.
Jello's in the house, and he said,
Jello's in the house. Hey, Jello.
Who cares about stars? Let's get back to talking about drums.
Oh, hey.
He apparently did not know that you were a drummer as well, and he's very excited.
Oh yeah. And you guess where that led me, Jello? I can tell you right now, or Obsessed House, whichever moniker you're going by tonight. Oh wow.
It is Obsessed House too.
Yeah. Oh, is he? Is he? Is he Obsessed House tonight?
Yeah.
Okay. Wow, this is just stunning. I'm gonna just do another one of those. I was gonna say, yeah, this led me to my drum career led me to doing primal rhythms, and I really like primal rhythms. And I started experimenting with the native rhythms, Native American rhythms, and I started looking into Native American flute because my mother was Native American, so it was very cool. And so I got into that. And with my ancestry, I could go to the Native American powwows and go into the sacred circle, and do that kind of thing if I wanted to. And you know, it was okay, it was fun, and I did a little bit of that. But then what I did was I started going now to a different Native people to learn a different type of rhythm. So I went to the Aborigines in Australia. And I actually started learning the traditional didgeridoo, which is a hollowed out log. And of course it makes the sound like the, you know, that sound. Well, that uses a special technique to do right called circular breathing. This is beautiful, guys, tonight. You know, and talking about didgeridoos and Lagoon Nebula just doesn't seem to work, but well, maybe it does.
It's funny when Jello said, "Does Mark play?" I said, "Yeah, he plays drums, guitar, and didgeridoo." Oh, I swear to God, I typed that like 10 minutes ago. Oh, so
I'm not even seeing chat, so that's actually pretty cool.
See, yeah. I don't lie. That wasn't a joke at the end. Drums, guitar, didgeridoo. It's a fact. And how many do you have? You actually collect them, right?
Well, I make them. So I actually have.
Oh, wow.
I make didgeridoos. I've sent some out, obviously. But I invented one didgeridoo that actually is, you know, didgeridoo is like a single tone. So you get when it's E flat, okay, or something, or A sharp, you know, or B minor, you know, B flat, whatever. But I wanted a didgeridoo that I could play with anything I did. So I would actually create live tracks because I have a you know, whole system where I can actually have a keyboard which I can play with you know, special instruments on it that are just electronic versions. Sampled sound, and then I put that together with real stuff that I do. And you know, I'm not really a musician, so to speak, and I do this just for, like, when I was teaching and doing other videos and stuff, or sorry, other lectures. I would just take some of my cuts and put them behind because I couldn't get in any trouble for that. I couldn't get in any trouble for using my own music. You know what I mean? Well, anyway, when I started looking at and experiencing the didgeridoo, I started to realize that, you know, because it only plays one tone, it has a limited place to be used in some of these songs. But if you could have you know, you have a song and say there's a key change. You know, there's a key change in songs, like it goes dun 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 dun. Right? Those are key changes, right? Well, the didgeridoo, if it's going, you know, when it goes dun 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 dun, the doesn't work. So you want to be able to go right? So I figured, what's so hard about that? Why can't I make something that I'll call a digibone, like a trombone? So I made, first of all, I studied how the didgeridoo worked, and I figured out what's going on. It's a standing wave inside a long tube. Well, the pitch was dependent on the length of the tube. So I said, oh, well, great. If I just make a didgeridoo that has an outer pipe around it that can be slid down and back, it will effectively lengthen or shorten the tube. A digibone, like a trombone, but for a didgeridoo. So I tried it, and the first time I played it, I went, it's like, whoa, that's so cool, you know. And then when I looked up, whether this was something brand new, I found out that no, this was something that some people have already explored and, created in the past. So I didn't create anything new, but I thought of it new, and that's the thing that I thought was important. I was able to think of it, and then do it. So the digibone was interesting, and then I got people saying, "Oh, but I want a didgeridoo. I want a didgeridoo." So rather than go find termite-eaten logs, okay, what I ended up doing was I ended up going to Home Depot. And I discovered that by going to Home Depot, I went to the PVC pipe aisle. And my local Home Depot thinks I'm an absolute nut because they see me and they go, "Oh, look at here comes the digi guy, or the wacky guy who plays the pipes or something like that." They make, and then I pick up one of these long, 8 or 10 foot sections. I put it up against my mouth to feel whether it's got the right spacing, because you gotta have the right spacing for the lips, and then I make a dig sound, and of course at that length it's a hugely deep sound that reverberates throughout the store. And people they look up, and the Home Depot guys, they walk by, they don't look at me, and they smile, they go, "Oh boy, he's here again." So I would buy them and I would cut them apart, and I would tune them. I would get them to the right pitch with my tuner or the keyboard, and so I'd make, like, say an E flat or an E major, a didgeridoo, or an A minor or whatever, A flat, and I'd make a bunch of them, and then I'd paint them to look like they have tribal stuff on them, tribal looks. And I'm not doing it from a point of view of anything but my mind. I'm not doing it from any traditional background, and I'm not trying to make it sound like I can do that. So I think it's kind of cool. I like the concept of the didgeridoo. It's a really, really pleasant sound. It's outrageously enjoyable, and you end up getting animals that will come, and it's like, don't ask me why, for whatever reason. It's one of these that I'm moving the telescope, by the way. It's one of these things where you can actually spend a lot of time trying to tune it and all that, but then you get the sound right, and bam, the sound is just, it's there. It's gorgeous. It's stunning, and it's like, and I remember I was playing, and I remember going outside around midnight, and I was actually playing out on the front porch just to kind of unwind from the day, and I'll tell you about this star in a minute. And when I did, I started playing the dig, and I really had a interesting experience. As I was sitting there, and as I was playing the dig, I started to realize that I was beginning to vibrate because of the didgeridoo. It's a vibrational tone. It began vibrating in my head, and I began imagining that there was, like, a couple of raccoons sitting down at my feet listening to me play, and when I'd stop, I wouldn't see them. So I figured, wow, this is kind of weird. And then I'd play again and play some more. And as I was done playing, I would turn around, put the ditch down, take a break, and when I looked down at the ground, there were two raccoons at my feet, and I was like, "Whoa, these little guys were sitting here all along," and I guess I missed them. You know, they would blend in or and so forth. But these are like raccoons, and they were like listening to the music. They were drawn to the drone, is what I said, and it's like, wow, this is crazy. And so that was a start of crazy happenings, you know, with animals, which was kind of weird.
It wasn't Rocky, was it? You didn't name her Rocky, but you had one that you named that had babies.
Yeah, that was actually a skunk. That was the skunk story.
Oh, the skunk. Oh, yeah, that's right.
But see, what preceded all that stuff with the animals was that they're coming to see me was this didgeridoo event with the raccoons. And I thought that was just cool, you know. And I found that when I stopped playing, there was dead silence. Dead silence. Every single cricket, everything that was making noise was done. It just stopped. And then as I stopped, then all of a sudden you hear, they'd start back up again. It's like they were stopping, maybe because, you know, in reality, maybe I disturbed them. But, you know, it was just really funny.
Gave him a heart attack.
Oh, maybe I killed a few grasshoppers. I don't know, but I hope not. But anyway, the raccoons really love the song, the music, because I was also doing vocalizations through it. You know, there's a number of vocalizations you can do. You can imitate a lot of animals through the didgeridoo, and the Aboriginals will use the didgeridoo for Dreamtime stories, and they will tell stories using the didgeridoo. They won't use words. They just play this drone, and then you listen to this music, and you hear the sounds that belong to different animals. So you say, oh, here's the hunter. He's walking out in the outback, and he sees a kangaroo. He follows the kangaroo, and he accidentally runs by a kookaburra. And then the kookaburra finds a dingo, and he follows the dingo back to its den. And there's a lot of little dingoes in there. And then, you know, he goes back to try to find the kangaroo. And then he finds the roo, and he follows the roo back. And you're hearing this through the music, through the drone. It's all played, and the vocalizations he's doing are animal sounds. And so you recognize it, and it paints a little picture for you. And it's just, that was crazy. And it's like, wow, you know, really, really descriptive. So when I say I went primal, that's what I mean. I went primal with my rhythms, and I ended up doing that. And that's why Stomp is so great for me. I love Stomp. I love listening to it. I love going to see them. Blue Man Group is great too, but keep in mind that Blue Man Group is more contemporary music. It's not sound. It's not sound rhythms. Okay, it's music written with you know, the guys in blue playing these special PVC instruments, and the sounds, of course, are unique in and of themselves. But I just loved the sounds of Stomp. You know, opening a door, and you know, that becomes the basis. And I have an application on the iPad here and on my iPhone where you can actually lay over tons of these different rhythms, and you can just create a song right there on the spot. Bam, bam, bam. It could take you 30 seconds to create one, or 10 minutes, or if you want to. And you can make these songs, and all you do is you start these rhythms, start and stop, and then they play back. And then over those, you play something else. And over those, you play something else. Over those, you play, oh yeah, oh yeah, oh yeah. And then that keeps coming back. And you just keep playing over and over and over, and you just layer all these things in. And it's really just stunning. It just comes out beautiful. You know, and it's really good for doing, you know, relaxation, if you really need to relax. You know? And I tell you, you know, if you're in touch with that, like my mother was, like I said, with a Native American heritage, I ended up always being in touch with nature, always feeling, whoa.
What was that?
Wow.
See, now that's how fast the other thing moved, and I figured it was a bird.
That is not a bird. This is a satellite just went racing through this field. Guys, you're going to see it in a couple of seconds.
Yeah, but they'll hear it when it passes.
Oh.
Oh, I just put it in chat.
Wow. Absolutely amazing. It was just beautiful. It was very bright too. It was not a meteor. That was too fast.
Zone 2 to zone 4?
Yeah, I don't know if they
Maybe?
know that.
Some of them do. Well, okay, we usually...
Center top to center left. Mid left.
That was bottom left, I would say.
Really? I can't rewind from here, you know.
No, I know.
That was really stunning.
I had the chat popped out on Skype, so it blocked the time, so I didn't actually see it. Oh, times are coming in now.
Awesome.
22:18, 22:17:59. Thank you, Daryl. Thank you, Prow.
Hey, Daryl.
What we usually do is divide this into 6 spots. So the top left is zone 1, the top middle is zone 2, the top right is zone 3,
right, well,
the bottom left zone 4.
Let me say this before it goes too long. We're actually on the star Alia, which is Theta 1 Serpentis, okay? And this is a beautiful double star. And just so you know, the actual location is 18 hours, 57 minutes, 5.29 seconds. Right, ascension, declination, 04, 13 minutes, 45.3 seconds. Why am I saying that? Because at this particular time, now we have everything we need to go find out what satellite that was. We can find out. Because we can look at the satellite pass and figure that out. So, since I'm running the telescope, Daryl, it falls on you to do that. So let us know when you find it.
No, they found it. 22:17:59.
No, I mean...
Oh, what satellite it was.
Yes, you can determine which
if
satellite
someone
it
find
was.
that.
Yeah. Now, I'll just say a little bit about this double star, by the way. This double star is 155 light years away. It's beautiful. Okay, it's really 2 stars. Remember what I told you about double stars? Okay, they are typically similar. You'll probably find that they're both the same kind many times. If they're drastically different, then maybe they're just visual doubles, meaning that one may not be gravitationally bound to each other. They didn't form together. Maybe they captured each other as they're traveling through space. But Alia is a really just a fundamentally beautiful double star. And even a small telescope will show, it's this beautiful 5th magnitude pair. And you can see that. I don't know if you can actually see it too easily here. Maybe if I do my defocus trick here.
Do we know which one is bigger?
Well, that's the thing. I'm trying to show you that one of them is actually brighter than the other. But it's very, very different. I mean, the magnitude difference is like a tiny bit.
Is brighter always bigger?
No, not at all.
Okay. No, well, that's coming up in chat too, and they're taking guesses. Sorry. But again, you can't really say, because I mean, I would say the one on the right looks bigger, but it could just be closer to us, right? So
yeah, but it doesn't matter, because if the star is a smaller diameter, then the star will not have the same luminosity, that is intrinsic brightness, because the luminosity depends on the radius, but also it depends on the temperature. So if it's a hotter type star, it depends on the 4th power of the temperature. So temperature drives what the luminosity is over the radius. But so that said, this star pair here are separated by about 900 astronomical units. So less than than the over 4,000 for Alberio. Okay, but these are just gorgeous ones. And now there's actually 3 stars to this system, and the only thing is that it's probably just an optical line of sight double, meaning it's not really part of the system. We only see this guy right here. But if I change the settings here, let's drop down from 20,000 to say 200. How's that for a change, huh? And then let's do a 5-second. No, let's do 640 and do 5 seconds at 640 at this here. And let's then zoom in and see what we got.
And our friend David from Thailand wants to know,
hi, David.
How could they have captured each other without revolving?
Well, they do revolve. I mean, you see, we're seeing the universe is slow motion in a lot of ways to us. We see a lot of sorry, I'm doing two things at once. I apologize. We see a lot of things happen when we look at the night sky. A lot of what we see, okay, is these two stars, for instance. They're separated by, say, about like 600 astronomical units, say, from each other. Well, they're orbiting each other, okay? And it's going to take some number of years, thousands of years perhaps, for these stars to go around. Okay, now I think the actual number is about 4,000 years for these stars to go around each other once. So think about that, and think 4,000 years ago what was going on here on Earth, and then think about that as saying, well, that means the star on the left was on the right, the one on the right was on the left, or say, or they had swapped positions with it. 2,000 years ago they had swapped positions. So, that kind of stuff is going on. The universe is still moving, even though we can't tell it's moving. And I just thought that this is a beautiful star for this. Now, both of these are A5s. Okay, that is A5 numerical 5 V, A5 5. So that means on the OBAF GKM stellar scale for the stellar class, the spectral class, these are class A stars, and they're right around the middle part. So from 0, 1, 2, 3, 4, 5, they're 5s, okay, and they are burning, that is fusing hydrogen normally into helium in their cores. So they're luminosity class 5, which is a Roman numeral V. So we see both of these stars doing what we expect doubles that really are true doubles to do, and that's have pretty much the same characteristics. This is really great. These are beautiful, beautiful stars. And it's hard to believe, if we just take another, let's just take another photo. I just want to show you something. If we look at, say, let's go to 2500 ASA, and let's go to 6 seconds, 2500 ASA.
Could you spell the name of this star?
Yeah, this star is
Alera?
called ALYA, Alya.
ALYA?
ALYA, Alya, yep.
I thought it was Alera or something.
No. This is Theta 1 and Theta 2 Serpentis. It's using the same Greek letter because the stars are a double star.
Both A's.
So it's Theta Serpentis. But when they discover that it's a double, well then one star became Theta 1 and the other one became Theta 2. Okay? So now, when we go back and we look at this overall, and we zoom in, okay, you can actually see what a beautiful little universal gem that is, a cosmic gem. I just want to take one more shot, and I want to pop it up to 6400 for 6 seconds, 6400 ISO for 6 seconds, and I'm getting chilly because my moon is up now.
Oh, because you did actually have some questions coming in.
Yeah, go ahead. You go right ahead and interrupt me.
Okay, I'll ask this one first because it's related to what we're talking about, and then I'll go back to some that I was just holding on to.
Okay.
Okay, Ronald wants to know...
Hi, Ronald. How's it going, man?
Is it more strange to only have a single star like our sun? Most are double, is this right?
Actually, Ron, you're actually on the right track, actually. There are many stars out there that are double stars. It's rare for stars to be triple stars, and in quaternary systems even, but it's not rare for a star to be a double star. We find there's a healthy collection of stars out there that are also doubles. We also find that there are double stars that have planets circling them farther out. So you can imagine the odd seasons that would occur on planets like that, because when the stars are side by side, you're getting double the intensity. when the stars are one behind the other, you're getting half the intensity if they're the same type of star like these. And so you would have a very, really strange summertime, wintertime, seasonal shifting with something like this, because if you even had we have seasons because of our tilted axis. Okay, we're 23.5 degree tilt to our plane of the orbit, and so the northern hemisphere is farther away from the sun for part of the year, and closer to the sun for the other part of the year when it goes around the sun. When that happens, we get seasons. Now, if the sun was also a double star, we would also get a seasonal variation at a smaller, at a much smaller time frame than 6 months to change seasons. Okay, we would get the seasonal time frame based on the orbital rates of that central pair of stars in our solar system, if that's what we had. And we don't have that. We actually don't have that. We don't have that in our solar system, but we do have one star, and our obliquity, or our tilt of our axis, of that 23.5 degrees, is just enough to provide a major change in our weather, every few months. But 2 stars in the system would change them as well, because as you know, like I said, when they orbit each other, they can be side by side. Say they look like this right now. Okay, like right there. Okay, if they were side by side, like I said, you get double the intensity of the starlight. And if you only had one star facing us because one was behind the other, well, the radiation from the star behind the main, the first star, isn't going to get to us, and so that would, cause us to have cooler temperatures for a period of time. Now, if they orbited each other once every 62 days, well, then we would get a strange mini cycle of summer and lesser summer weather along the way. So it could be very complicated. And if we had an obliquity change, like an angle of our axis was off from the plane of the solar system that we're in, then we would end up in another, a totally different situation. We'd have seasons that are really strange. And of course that depends on how far away we are from the star and so forth. But I just think that's so cool. Man, that's so cool.
Ted wants to know, okay, did you say the distance between these 2 stars is roughly 900 astronomical units?
That's correct.
Okay, so he says in terms of miles, that's just under 1 billion, correct?
Well, yeah, just take 900 times 93 million.
Okay, so he wants to know, isn't that tremendously close for 2 stars today?
Well, keep in mind that Neptune is 30 AU from the sun. 30. Okay? The Kuiper belt is up to about 50 AU from the sun. And these stars are more than 10 times farther than that apart from each other. So would one of these stars with an entire solar system around it, if it could have, actually be affected by the other star? And the answer is, well, yeah, in some ways, maybe gravitationally, there might be some perturbations. But would the radiation from a star that far away really affect things? The answer is probably not much. Now, it might be bright in the sky, brighter than Sirius is in our sky by far. But it's not going to be as bright as our sun, which is, in terms of magnitude, the sun's like minus 26 or so brightness, And when you look at these stars, we'd have a bright star. The bright companion would be visible in the sky, probably day or night. But its radiation probably wouldn't affect us. But the gravitational field would to some extent. Anyway, I hope that answers the question.
Okay, yeah. Sorry, too many screens open here.
You're good at that.
Okay,
and by the way, I just want to say to the chat, hey folks in the chat, please wish Amanda good health, because she's actually suffering from a very bad sore throat and a cold right now, And she's still...
it's just a little head cold. I complain more than it's actually.
Well, you were complaining all day. No, I'm just kidding.
I was sleeping all day, actually.
She was. But just
more so than usual, and that's scary.
Send her good wishes, folks, because she actually is taking time out of being sick to come out here and help me with all this tonight. And this, as usual, she's doing a great job.
Oh, thank you.
Yeah, of course. You do great stuff for me, and I can't forget it.
I said that right at the beginning of the stream, before we went on air. I said, I probably won't be doing a lot of talking because my throat's killing. Yeah, right. Me not doing a lot. This is it. This is me not doing a lot of talking, so.
Yeah, that's pretty good. Yeah, for not talking, she's certainly talking.
I'm getting pity from the chat already. It worked.
Oh, good for you. I'm glad. You deserve it.
Thank you. Now, Lacey, I think she already took off, but she actually wanted to see stars that you can see more often, like stars in the Orion Belt. Now, I know that's more a winter constellation, but is there something that, like, I don't know, things that you hear often, names that we all know that possibly we could look at before you freeze? There's still a few more questions, too.
Well, nebula-wise, that's not going to be possible because we've got a major. The moon is out. Yeah. I'm going to pause right now with this, and I am going to change us back to the non-filtered view. Okay. So you're going to see the red again, and then that red's going to go to the bright white right around now. So don't look. The supernova will be over shortly. Okay, I'm just gonna...
Okay, well, while you're doing that, actually, Ronald wants to know, do you do processing before you post these? So, I guess he's talking about the Facebook group, SkyTour LiveStream with Berg D'Antonio. I'll put the link in a moment. Do you do any processing before you post them?
I do process some. But I also upload the raws, and I say, in fact, in the captions, I say, try your hand. And I say, you try the processing. You know, because it's really a lot of fun. Okay, now.
Link is in chat.
Thank you very much, by the way. Let me,
And... Now, this one I missed, so I'm not sure what David was referring to. It would have been pretty far back. Sorry, I didn't realize it was a time-sensitive question. He wanted to know what caused the purple pinkish color. So I'm not sure what we were looking at, but
that was probably...
Is that general enough to apply to other stars, or does it depend on what we're looking at?
He might have been talking about when we were looking at the Trifid Nebula, and I'll answer that because that's relevant for that. The purplish pinkish is actually the result of ionized hydrogen being, ionized hydrogen being caused by a hot star in the center of the nebula, and that's what we were seeing with the Trifid Nebula. Okay, and that's something that's really, again, that's something that's actually quite, easy to figure out and follow, because the hotter a star is, the more it can have, the more ability it'll have to excite, the nearby gas around it, and that's exactly what we see with that. So I think that's what he was talking about. But if not, he'll tell me.
Oh,
I'm sure I'll hear from him.
Yeah, for sure. And a great question. Jeff wants to know, do stars ever collide?
That's interesting. In a generally speaking, collisions of stars would be catastrophe in the making, because they're fusion furnaces, so they're fusing fusing new elements in their cores. They're fusing in their outer envelopes, the outer part of the star, they're fusing differently perhaps than in the core. They're very complicated, And as I said, for my degree, one of the things I had to do was build a star from the very core all the way to the outside. And we actually had to generate a computer model of what a star looked like from the inside all the way to the outside. And it was pretty rigorous, but that understanding made me realize that should stars ever come near each other, a number of things can happen. Let's take a look at this blue and orange star here. This double star that we're looking at now, okay, is not subject to what I'm about to say, but we can use it as an example since it's up. This is actually a beta 1 and beta 2 Capricorni, which is Capricornus. All right, beautiful naked eye double. It's around 330 light years away, so it's just great. And the stars that we're looking at are beautiful. It's really a K0 bright giant there on the left, probably anyway, and it's basically the governor star of that pair, because it's actually quite a large star. It is it is a giant, as I said, but that secondary star on the right, that's actually another B8, just like we saw earlier with that other for the other double we were looking at with the B8 star and the K3 giant. Remember who we were looking at? Wasn't that Alberio? So anyway,
we just looked at?
No, just now, but earlier we looked at Alberio, and it was the K3 giant with the B8, right?
Oh, okay, yeah.
Well, that star on the right of the pair there is actually a B8, and when we look at it, if I just go into it one more time here, let's go in. So you can see now that B8 on the right, that giant on the left. There's actually more than two. I know you see other stars in the field, and to the left of the K0 giant there, which is slightly orange, as you can tell, you can see another pair of stars. Those may or may not be actual double stars. They're probably optical doubles. That is, double stars that are just aligned because one's nearer to us, one's farther, and they just happen to be along the same line of sight. But you never know. But these stars are at the same distance, and so based on that, we know that they're probably double stars, probably related to each other. Interesting to see, because there's a whole litany of things you can go through and tests you can go through to see whether they're actually together, doing stuff.
Well, that's what I wanted to know. How could you focus on the two smaller ones on the left and defocus them to know, or I'm sure it would take a lot more science than that, but
yeah, I mean it would take a lot more than that, because defocusing them doesn't, as far as we're concerned, everything out in space is at the same distance in terms of the telescope. Not in actuality, of course, but the telescope focuses to infinity, but not really infinity. Really,
one of the 5 levels of infinity?
Well, yeah, no. It focuses to a level that is, for all intents and purposes, as far out as it can focus. And so once it's there, everything else is in focus, no matter how far away it is beyond that. Which is kind of odd. If you focus on the moon, then focus on the star, you find that the focus is identical. So it's kind of weird, but that's how telescopes work. Same with binoculars. There's zones of focus where everything from a certain distance to a certain distance is in focus, and the farther out you look, then the bigger that zone is. So when you're out as far as stars, when you focus on the stars, then every star is in focus wherever you look. So that's kind of what we're seeing here. I just like the colors. I really love these colors, and I want to just do a quick thing, because this is now a live view here, and I want to go into this live view. Okay, there we go, and I'm going to bring us down here, and now let's defocus and see what we get.
Things I was just about to say, when you were saying the one on the right was blue and the one on the left was orange,
yeah,
I was thinking the one on the right is so clearly blue,
Yeah.
but the one on the left kind of looked more whitish to me. And then that was in the picture. As soon as you went live, before you defocused,
Yep.
the blue barely looked blue. It looked all washed out and faded, and the one on the left looked really, really orange.
Well, that's interesting because obviously the one on the left is a K0. So what comes before K in the spectral class? What's before K? What's just before K? Right, is G,
Got
right?
Girl. Oh, G. Yeah, sorry. I was going through the...
No, yeah, I know. And that's good. Right, but that's right. And so basically G stars are, for all intents and purposes, like a slight yellow, whitish to yellow. And that's what we're seeing here. We're seeing a star that's still kind of like a little bit of a yellowish. It's not quite orange yet. If it was a K5 or a K7, it would be very orange. You'd notice it very much so. So this is what we see, and this is how it works. At this point, you don't see too many things. You don't see much color here. You have to kind of defocus to get that color, and that's actually kind of a neat little thing to do. And of course, taking a photograph generates color too. We saw the photo that we took. Okay.
Well, that's what I was wondering.
That
like,
photo, you can clearly see the color. There's no missing that color. So that's something that's really important, and I just am just absolutely in love with this star. It's just beautiful. Okay. Now that star is actually that double star, I should say, is beautiful. But I want to look at one other one here if we can. I want to look at one other one here.
Okay. Well, while you do that, David wants to know, how deeply can modern instruments see into stars the way they've analyzed the layers of our sun?
Well, you know what? That's a really good question, and in fact, I like the way it's even phrased.
He's a really smart guy.
Yeah, he is, and I'll tell you why. Because if you're gonna try and show someone how we understand the chemical element factories in stars, you would say that we would be looking deeper into a star's layers to figure that out. I'm going to move now just a slight different distance away. It's almost within the same field.
Yeah, the second part just came up. He said, or can we just analyze the spectrum of their light to determine chemical composition, distance, etc.?
And that's exactly right.
There you go.
Almost. I mean, we can't use we can use the spectrum to determine its chemical abundance. That's correct. All right, but we can't take that abundance, for instance, and try and figure out whether there's a distance associated with that at all. We can't find the distance from that. Okay, and the distance comes from relationships we've built. There's relationships between the brightness of a star and its mass. There's relationships between the brightness and its distance. Okay, that's called the distance modulus, and that distance modulus is calculated based on knowing two or more values of a star, and then we can calculate all the rest. And that's, if someone wants to know about that, we can go into that at some point. But it really is basically, that's, now you're talking about being an astronomer, and that's great.
I want to know about that.
All right, well, we'll go into it. I'll do that. That'll probably be a cloudy night stream, because I'd want to show you more than just pictures of like stars on the screen here. So now we're looking here. This is the brightest star in the constellation Capricorn. It's Alpha Capricornus, but as you'll notice, it's Alpha 1 and Alpha 2 Capricorni. It's actually a double, and
we were just looking at Beta 1 and 2?
Yes, we were, and they're actually right next to each other, right next to these. A little, not far away, I should say. So now, both of these stars are a little bit orange, as you can see. But you know, they're similar. They're similar to our sun in kind of name only. They're a little more orange than our sun is, obviously.
Are they both G's?
Well, actually, the star that's Alpha 1 Cap, Alpha 1 Capricornus, is actually a giant that's like 43 times more luminous than the sun. But it also has very few metals, which means that it's probably a lot older star, of course, because it wasn't formed when there were enough metals in the universe to actually, you know, put them into the stellar atmosphere upon formation. And so it's basically an older star. This comes from an older population of stars, and the other star is a supergiant that's actually 930 times more luminous than the sun. Okay, and it's 21 times more luminous than the first star. Yet it's seemingly fainter because of its greater distance. Okay, so it's the larger of the two. You know, with a radius, it's about 40 times that of the sun or so, and it's a massive. These two stars are not conducive to life in any way. Okay, these stars are giants, and so there's no mistaking the fact that they're just not going to provide any kind of sustainable life. Now, you asked me about the G stars, and I kind of hemmed and hawed on that for a little bit because I had to explain that they're giant stars, meaning that, you know, the temperature, all right, at their surfaces makes them look a little more orange. Yet they're actually G stars. They're G3s, but they're 1b supergiants. So that's G3 is the actual spectral class, and the 1b is the luminosity class, which is supergiant. And so they do look orange because of that large bloated appearance. Okay, and you know, the interesting thing is that you know, that together these stars are 619 times the luminosity of our sun. So that's just incredible, you know.
So, okay, so they're both G3s.
Supergiants. Yeah, G3, and then there's their G3 spectral class, and the luminosity class is 1b. That 1 is a Roman numeral 1, and then a little b. That's how that is. And it'd be great if you guys could, if you wanted to look up the difference between what a 1b is and a 2 and a 3 and a 4 subgiant and a 5. I mean, all stuff that you want to, not subgiant, subdwarf, and 5, you know, dwarf, they're called, like our sun. I'd love to see, you know, what you would think of that. We could have a nice conversation.
See, I'm holding my questions because I'm really lost and I don't want to confuse anyone in chat. So
okay, well let me just take this back.
No, okay, but what are they in the little mnemonic though? The "Oh, be a fine guy, kiss me."
Okay, they're both G.
They are both G. Okay,
yes.
But since they're technically okay. G3? Because you're saying 3G.
No,
as
no.
if something else. But, like, is every...
No, I said G. I said
every G3 star a supergiant?
Nope, not at all. It's the classification is just based on its temperature, and so forth. The luminosity class is a little bit different. That has to do more with its luminosity, which is related to size. And the larger the star is, the temperature, you know, gets lower when it's larger in diameter. It's first of all.
Sorry, I know.
I know. There's so many things here that I'm hitting you with. And it's crazy. I know.
We'll see, but I'm sure a lot of people in chat understand at least bits and pieces of the majority of what you're saying, if not all of it.
No, I mean
so I think I know what's going on, and then you hit me with like a new term and a new way of looking at it. So I'm trying to relate it to the little bit I know, and
yeah,
sometimes when I'm really off base,
yeah,
people tend to get confused by listening to what I'm saying, so don't listen to what I'm saying. I'm here to learn too. Yeah. But that's, like, you know, like, I don't know, if every kind of A1 star was also a red dwarf or something, you know what I mean? That's what I'm kind of looking for.
You're looking for something that doesn't exist, actually.
Well, figures, yeah.
Yeah, now...
That's where I'm getting confused.
Well, where you can find some unity there is in the fact that there are relationships that we've learned in astronomy that relate to, say, the mass of a star versus its luminosity. Okay, there's something called the mass-luminosity relationship, and stars of a certain mass will tend to have a certain luminosity, within the spectral class. Okay, so within the dwarfs, within the main sequence stars that are that Roman numeral 5, the V star, are all in the main sequence, the normally fusing hydrogen to helium dwarfs. You can say for one of those stars at this mass, here's its expected luminosity, and it'll be pretty much right on the money. There's other relationships that talk about the distance versus the luminosity, and that's related to the brightness of the star as seen, say, in another galaxy. And you want to know the distance to the galaxy. Well, what we can do is we can look at the fact that some of the stars in that galaxy are variable stars, and named after one particular star of the class called a Cepheid variable. We can look at the rate of change of the star. We notice the relationship between the period of brightening and dimming of these variable stars, because a variable star is one that changes its brightness over time, but in a periodic, rhythmic manner. So when we look at a Cepheid variable, for instance, in our own galaxy, the Cepheid variable will, say, brighten and dim over, say, a period of 5 days. Yeah, that's typical, And we might notice that. Well, that also corresponds to, once you know that brightness, if you can convert that brightness to a standard measurement, like an absolute magnitude, you can then figure out how far away the star is based on that brightness. And why do we know that? Because that brightness for these particular stars doesn't, that brightness stays the same for a star of a certain period of dimming and brightening. So for a period of 5 days, the star is always going to be this brightness, say. And thus, you can know the distance of that star just by comparing it to others of the known similar type. So I guess what I'm getting at is there's an awful lot in astronomy that depends on comparisons to other known objects, and this is one of them. The distance-luminosity relationship is something that is a fundamental one, and you use, like I said earlier in the stream tonight, you use something called the distance modulus to determine that, and the distance modulus is something that I could go through and I could develop it for you and show you where it comes from, but unless you're an astronomer, you're probably not going to ever use it. But I want you to understand where it comes from, and it'd be cool to see where it comes from in a way that you can understand it. You don't have to be an astronomer to know how it works for us, in other words.
I like knowing how things work, because if I don't know, if I don't understand, I really, really got myself confused.
Oh, I
and not that I ever need any of this stuff, but I like knowing, just because I like knowing.
I think that's great.
So, okay, well, Daryl was trying to explain something as well.
Yep.
Okay, so, like, this, the mnemonic, that thing that I have, that, oh, be a kind guy, kiss me, that's for the luminosity. So that's only dealing with luminosity. So so that's just one scale.
That's actually for the spectral class, which is based on the temperature.
For the spectral, okay. So then you have a whole different system for the distance.
Yes, I mean the distance. Knowing all the things about the stars that we do, the temperature and all that, is all well and good. But there's other there's other rules that govern what tells us the distance of the stars. And by the way, I just want to show you this here. This star is called Fomalhaut. All right, not a very impressive star just by looking at it like this. But it's pretty, yeah, for sure, no doubt. And I'm going to do a 10,000 ASA shot here at 10 seconds. I just saw something large and black fly over the dome. I have no idea what that was. That was really crazy. All right, and we'll look at this for a second. I want to show you this when we get there.
But it's because earlier you said, like, if you know 2 different variables, you can figure out everything else.
Yeah, that's
it could
true.
be any 2 variables as long as you know 2 of anything, right? So one could be temperature and one could be distance, or like luminosity and. Yeah,
we can't generalize it like that totally, but you know, you're on the right track. If we know.
Okay, so that's how you. Is that how you figure out like what's a giant and what's a dwarf? Like, if these kind of variables all line up, chances are we're going to end up looking at this.
Mm-hmm.
So that's kind of what I'll... So I only know... When you say what kind of star is this, right now I can only tell you, like, O or G or K or B or whatever.
You can't.
So that's the only one I know.
Right, and you can't tell the size of the star, okay? Not without further analysis, further study to find out, you know, if you can get its distance. If you can get its distance, then you get its absolute magnitude. In other words, how bright it would look at a certain distance from us, a standard distance. And if you do that, then you can figure out perhaps what kind of star, well, no, in other words, its luminosity class. There's relationships to help figure out that too. You know, getting the color of the stars is one thing. Getting the actual luminosity class, that is to say, what makes it so bright? You know, is it bright because it's big in diameter? Is it bright because it's hot and young? You know, what makes it bright? You know, is it a giant? Is it a dwarf? Is it a white dwarf? You know, given the right distance. Okay, this is the reason I'm showing you Fomalhaut here is for a couple of reasons. Number one, if you look at Fomalhaut here, okay, we don't see any particular color, but guess what? This could be a white dwarf. It's not, but I mean, it could be. All right, it could be a white dwarf, but a white dwarf that's close to us, because a white dwarf that's close to us would look like this. You know, but Fomalhaut is an interesting star because Fomalhaut actually is in my exoplanet presentation as a interesting star because of the fact that it has, besides being a double star, you know, Fomalhaut is 25 light years away, but it also has a potential planetary system forming around it, which is really cool. And I used I think it's from the Spitzer telescope, the Spitzer data to show the infrared details of this star, showing that there's a little planet that's tracking along the outside of the dust disk that surrounds the star. It's very cool. You know, really nice. I have to tell you guys, you know, I'm really, really happy that we got what we did tonight. And I am getting cold, but if any of you want to, you know, if you want to see the moon, I can show you the moon right now real fast. You tell me what you want to see. You want me to blow out your eyes at the moon? Yeah, I will if you like.
What other planets can we see?
Oh,
not that the moon is a planet, but you suggested the moon, which makes me think we're moon off stars, and I think planets.
Yeah, actually, no, that's a good thought, because I was thinking the same thing. Okay, good. There we go.
Am I warning people to watch their eyes? Are we going to the moon?
No, we're not going to the moon.
Okay. We could go to the moon. I really enjoyed that, what was it, LRO?
Oh yeah, a Lunar Reconnaissance Orbiter.
Yeah, that was really fun, because I enjoy going over to P&K Space Imaging, but I don't really know exactly what we're looking at. Like, we're looking at craters, yes, but I mean, I don't know what they're called.
Yeah.
I don't know anything about them, so that's a really handy tool, and it might not even be a bad idea next time they're streaming if Paul survives the storm.
He will.
You know, even having that little LOR app open, so when they're actually... Remind me to mention that to Keith.
Okay.
Because Paul's the one with the telescope moving things around.
Yeah,
Keith could probably have that little site open and say, right now Paul's focusing on that, and just even copy and paste some little information.
Yeah, he could do a picture-in-picture, you know, which I haven't talked to him yet about it, but I would like to see him do that.
Because I mean, he has enough people watching,
Oh, yeah, he does.
And a lot of people like me don't. I mean, it's beautiful, but you don't really know the details. That's why I like this channel, because not only are we seeing incredible images, but, you know, okay, what is that? What is that made of? Why is it blue? Why, you know? And we get the answers, and we, you know.
Well, this is kind of blue because it's Neptune.
Hasn't come up for me yet.
Oh, okay.
Oh, well, I mean...
Yeah, this is Neptune.
It has, but it's really small and far away.
Yeah, Neptune is 30 astronomical units away, or at least, and the problem with Neptune for us is that it being so far away, it's really kind of hard to you know, see it with any kind of detail, unfortunately, you know. That's sad, but it's true. I'm going to look for one other planet that is, I think it's up right now. And I'm not sure that I will, let's find it first. Horizon, oh, okay, well that must be up, right? It's in Sagittarius right now.
Ooh, there are your hints, chat. What's up in Sagittarius? Beat the clock, see if you can put the answer in chat before Mark zooms in.
Well, even if I zoom in, you still may not know what you're looking at. That's the problem, unfortunately, with this one. I'm going there now.
Chat will. I won't. I mean, unless it has a ring around it.
No ringy dingy.
Is it a planet?
Oh yeah, it's a planet.
It's Sagittarius right now.
It is. Yeah, it is. Alright, we're gonna do a 5 seconds at 12,800 ISO image, and let's see what we get. Chilly jelly.
Okay, well, no, I mean, I think I got to all the questions.
Okay.
So.
Okay, so, oops. Here we are. And one of those dots is Pluto. I'm not sure which one it is.
Wow, I was gonna guess Uranus.
Yeah, no, it's not Uranus. It's Pluto. Good old Pluto. I'm gonna see if I can get a better
But
view
you
here.
don't know which one?
I'll figure it out. Hang on. I'm gonna work on this here. Oh. Okay. Just a minute. Let's see. Let me zoom out a little bit. Actually, you know what? We're gonna do this by a little bit of sleuthing. I'm gonna go to a star right nearby. Okay, this star is right nearby. Okay, this is called a star Albalda. I'm gonna go there now. We're just gonna go real quick. It's barely even moving, and we're gonna see where it falls in the view. Okay, there's Albalda. Now see where it comes in. That's the bright star you're seeing. And then, bam. Okay, now that corresponds to just above center, correct? So what I'm going to do,
Basically, yeah.
I'm going to do this. I'm going to zoom in. Okay, So now I have basically a little spyglass on that area right there, okay? All right. Technically, because Pluto is right nearby, I'm going to go to Pluto now, and Pluto should be the thing that's closest to the center. Here we go. Oh, hey, look at there. There it is. There it is now.
The orange at the top?
Yeah, hang on. I'm going to try and figure out whether it's that
I'm
one.
getting so excited.
Hang on. I know, isn't it great? All right.
See, I already typed it. Steve just dropped by. He said, is he hitting outer planets? I'm like, yes, this is Pluto. I'm like, well, wait. It will be momentarily. Hold on.
Yeah.
So, I don't want anyone getting confused. That bright white star was not Pluto. This is Pluto here.
Yeah.
By the time you're hearing my voice now, because I'm live,
right.
Caught up. Yeah, this is Pluto.
Yeah, this right there, right above center. That's Pluto. Say hello. There it is. Now, let me just take a quick photograph of this. I'm actually going to center it up now. Oops. Let's zoom in on it again, just to confirm, because there's another test I can do to confirm. Oops, mistake there. Yep, that's my confirmation. By zooming in on it, I can see that Pluto has enough of a diameter so that I'm not getting this starry twinkle effect. Okay. Now it's low to the horizon, so it's getting a little bit of disruption from the sound from the turbulent atmosphere. But this is Pluto. Ta-da! Yeah, this is great. Now I'm going to photograph it. I'll do 5 seconds at 12,800 with it right in the center.
Yeah, Daryl is saying it looks awful bright for Pluto. Steve's first time seeing Pluto like this.
Well, you have to remember also that I'm using a larger telescope, so we're seeing it. See, that's what Neptune looked like when we looked at it, and Neptune's much bigger. Now the alternative is this. There's another one down here. The problem is, see, because Pluto moves enough against the background. We have to basically get a finder chart. I believe this is actually Pluto. I do believe this is Pluto. And so that photo will serve as a finder chart, so I can confirm it. But right now I believe that's Pluto. Don't forget, this is a 10-inch instrument with a very sensitive camera. Now I'm using a fairly high ASA right now. I'm using 12,800 ISO, so we're seeing stars in here that are actually quite faint.
David wants to know, where is Pluto on its orbital path at this time of year? Is it moving away or from or towards the sun?
Well, Pluto's in a slightly elliptical orbit, and it's inclined to the ecliptic a little bit. I'm not sure exactly where it is in its orbit at the moment, though. I pay less attention to Pluto, even though Pluto is very important to me, because I actually have the New Horizons data, and I've been printing out 3D imagery, 3D prints of Pluto's surface. It's really a very, very odd place. So I've been actually printing these out. Look at that, my battery's dying just in time, because I am too. So anyway, I hope you guys don't mind, but I'm probably going to close on Pluto tonight. And if that's not Pluto, I'll have to eat my hat, but I really kind of think that's Pluto. I really, really do. So I hope you guys are having fun. Did you have fun tonight? I mean, the beginning of the night was stupendous. Oh man, without the moon. If we get another few days like that, are we ever going to have fun? Oh man. we're going to do more of this. And I'm going to process a lot of these photos. I'll put some of the RAWs up for you so you can see them and play with them yourself. And I want you to have a chance to, go process these. If you have any questions about it, let me know, and I'll help you process them. I'll tell you what to go, what to get. Some of the stuff I use to process them is free, and you can't beat free. Let me tell you,
Yeah, and Mark's obviously part of the Facebook group too, so as he adds these pictures, just post a comment in there, he'll see it, he'll respond, and
I will
try to oblige as best he can.
I will.
As he does every time he streams for us. Thank you so much for bringing this to us. Again, free, live.
Yeah. Oh, you guys didn't realize you're being charged $14.95 a month. You didn't know that? As if. Yeah, it's beautiful. Right outside the observatory, I've got rabbits feeding in the grass right outside here. They're taking advantage of the moonlight, and they're feeding in the grass shoots out there. It's so cute. I come out of the observatory, and the first thing I do is they skitter in all directions. Like, hey, my lawn rodents ran away. What happened? Wow. Well, I'm really happy that you guys joined me tonight, and I really appreciate that you came. I do have to go in and get warm because I am really cold, but I just couldn't help it. I mean, I had to show you some of the things we saw. This was just incredible. I just loved it. And I want to thank you for joining me tonight. This was just great. Excuse me. So remember, if you guys actually want to, tell your friends, subscribe, man, I'd love it. And both Amanda and I want to thank you for joining us tonight in the SkyTour LiveStream for this evening. We had a great beginning of the night. The moon came up. We saw a little bit of the moonlight affect our images, but overall, well, we still had some pretty good views. We got some beautiful double stars. We saw some K supergiants and some B8 stars, and it was just beautiful. So just do me a favor and click that bell so you can get alerts when I start up next time. And I thank you so much for coming out and spending this chilly night with me here in the observatory, the John Zach Memorial up in northwestern Connecticut. Hopefully, in another year or two, we will be in Arizona with the John Zach Memorial Observatory, and we'll start anew under a dark sky. But my thanks to everybody. Thank you guys in chat. Thank you, Amanda, for modding, and thank you for all the questions. You guys are great. And I will talk to you tomorrow.